Right. Ellipse is x square upon a square plus y square upon b square is equal to 1. I'm not saying a greater than b or b greater than a. है ना? No problem in that. Now what I'm doing is I'm putting this line in this and making a quadratic equation. X square upon a square plus mx plus c upon b square, mx plus c whole square divided by b square is equal to 1. This is a quadratic equation. If its discriminant is greater than 0, what will happen? That this line will neither intersect nor touch the ellipse. If its discriminant is 0, then this line will be touching this ellipse. And if its discriminant is less than 0, then it will cut the ellipse at two distinct points. So when you will be finding D, you will be getting something like this. Find its D. And if D is 0, you will be getting a condition C square is equal to A square M square plus B square. If you find D is equal to 0, you will be getting a condition C square is equal to A square M square plus B square. C square is equal to A square M square plus B square. Now this is the condition of tangency. This is the condition of tangency. M square, A square M square plus B square. Whatever be the coefficient of A, if it is greater than B, then also this will happen. If it is less than B, then also this will happen. So C square is equal to A square M square plus B square. That means if you want to draw a tangent of M slope, line's equation will be y is equal to mx plus minus root over A square M square plus B square. That means line which is tangent to the ellipse is equal to mx plus minus root over A square M square plus B square. This is the equation of the tangent to the ellipse of slope M. Any problem? I don't think you will be having any problem in this. So this is the equation of tangent to the ellipse of M slope. If the slope of the tangent is M, then you will be getting the equation like this. What about if the line is tangent at any particular point x1 comma y1 on this ellipse? If this particular line is tangent at a point x1 comma y1 to this ellipse, next is if you have any point on ellipse, that is let it be x1 comma y1. If you have any point on this ellipse, let it be x1 comma y1, so the tangent's equation will be t is equal to 0. That is x1 upon a square plus y1 upon b square is equal to 1. This is the equation of tangent at a particular point. Then what will be the equation of the tangent? T is equal to 0. I have already discussed these things in circle. Then if this point is a parametric point, if this is a parametric point, then it is a cos theta comma b sin theta. Then what will happen? Sir, I will put this point. So it will be x into cos theta upon a plus y into sin theta upon b is equal to 1. This is the tangent to the ellipse at a particular parametric point. This is the tangent to the ellipse at a parametric point. Shall we discuss some questions now? All right, we'll be doing some questions based on tangents. Okay. You have written this? Everything about tangents? All right, so let us discuss some questions. Hold on. All right. Question number 11. Do question number 11 and 12. Based simple questions based on the formula. The equation of the tangent to the ellipse at the point whose ordinate is 2. There will be two answers possible for this question because there will be two such points whose ordinate will be 2. That means y coordinate. First question is very easy. Second is also easy. In the first question, your y coordinate is 2. That means 25 minus 16 x square is equal to 9. That means plus minus 3. One point is 3 comma 2 and other point is minus 3 comma 2. At 3 comma 2, you have to write the equation of tangent. Use t is equal to 0. That will give you the result. In the second question, you have to use the m form. That is, the slope of the line will be given because perpendicular to the line. So tangent slope will be m1 m2 minus 1. You can get that tangent slope from this. And then c is equal to c square is equal to a square m square plus b square. Use that. You'll be getting the constant term of the line also. And then put plus minus over there. You'll be getting two answers. Question number 11 and 12 are easy. I will not be discussing that. If you have done question number 11th and 12th, start doing question number 13. Any doubt in 11th and 12th? Any doubt in 11th and 12th?
Sir, 12th.
12th वाले में doubt है. The equation of the tangent to the ellipse which is perpendicular to the straight line this. Okay. The equation of the tangent to the ellipse which is perpendicular to the straight line. I'll discuss question number 12. Ellipse is x square plus y square, x square plus y square upon 3 divided by 1 is equal to 1. This is the equation of the ellipse. 4y is equal to x upon 4 minus 5 by 4. This is the line to which the tangent should be perpendicular. So that is m1 into slope of the tangent is equal to minus 1. So slope of the tangent is equal to minus 1. This is its slope is 1 by 4. So slope of tangent is equal to minus 4. That means c square is equal to a square slope of the tangent square plus b square. That means a is 3, a square is 3. Slope this is minus ka 4 plus ka. What is b? B square is 1, right? Iska square minus 4 ka square. So 4 4s are 16 into 3. 48 plus 1 49. C square is equal to 49. That means C is equal to plus minus 7. So y is equal to minus ka 4x plus 7 and y is equal to minus ka 4x minus 7. These are the two
हाँ
tangents to
सर,
the
मुझे
ellipse.
2 आंसर आ रहा था इसलिए कंफ्यूज हो
हाँ
गया।
2 आंसर आ सकता है ना, 2 आंसर क्यों नहीं आ सकता? मैं बताता हूँ क्यों आएगा 2 आंसर. लुक, मान लो ये स्लोप है, क्रिएटेड एज अ सर्कल, एक पैरेलल टेंजेंट मिलेगी बिल्कुल ऐसी. यस, देयर विल बी 2 पैरेलल टेंजेंट्स. Acha, one more important thing I want to tell you. You can draw a tangent of any slope on this ellipse, which is not true for hyperbola. Hyperbola में slope के ऊपर there is a restriction, but in ellipse there is no restriction. You can draw a tangent of any slope. Why? Because this quantity is always positive. ठीक है, वहां पे माइनस आता है हाइपरबोला में, तो उसमें वो दैट क्वांटिटी इज नॉट ऑलवेज पॉजिटिव. So this quantity is always positive. That means you can draw a slope of a tangent of any slope on this particular line. All right, chalo. Do problem number 13. 13 is a good problem. Use parametric point, and it will be very good if you use parametric point. Take P as a parametric point, and then write the equation of tangent, and whatever it is saying, do that. 13th and 14th, kindly solve. Problem number 13 में, if you will take parametric point, it will be quite easy then finding the area and all. 13 question. Chinmay, you have done 13 question?
Yes, sir. I got A.
You got A. Okay. Ganesh Krishna?
Same solving.
Okay. Chalo, do 13, 14, 15. I will discuss it after 5 minutes. All
Sir, A.
Shall we discuss these three problems now? Yes. All right. In which problem you have doubt? 13th one. 13th one may you are having doubt? Yesterday that Susan and Pradame, you have doubt in 13th question? Its answer is A. Shall I discuss it? Yes? No? You can shake your mundi. Mundi hila do. I'll understand. Yes or no? No? Yes. Okay. Chalo, quickly I'll be discussing these problems. We have an ellipse x square by 8 plus y square by 18. In that we have a point P and we have a tangent. We have a tangent and we have a point P. Its center is O. This is A. This is B. Right. Now let me take any point on this. Let it be A cos theta and A sin B sin theta. B sin theta. So the equation of the tangent will be equal to, and I will put later on, I will put the value of A and B. So the equation of the tangent will be x into cos theta upon A plus y into sin theta upon B is equal to 1. Now, please tell me what will be this point B. If you put A as this y as 0, you will be getting A upon cos theta. This point will be A by cos theta comma 0. This point will be 0 comma B upon sin theta. Now what is the area of this triangle? Is half of A upon cos theta into B upon sin theta, which is equal to AB upon sin 2 theta. This will be minimum if sin 2 theta is equal to 1, which it can be when theta is pi by 4. That means minimum area is equal to A into B, which is equal to A is root 8 into root 18, which is root 8 is 2 root 2 and this is 3 root 2. 4 3s are 12. 12 is the answer. Now you understood? Achha, initially why didn't I take A? Because it was in root. That is why I didn't took A initially. Okay, next problem is problem number 14. Who will tell me how to solve problem number 14? Chinmay, you have solved problem number 14? Yes? No?
Yes, sir, but I didn't match it with the options.
Okay, you didn't match it with the options. What you did, can you please explain it to me?
C will be common.
C will be common. Problem number 14, beta. There is exactly one tangent. If there is exactly one tangent, that problem. Problem number 14, if there is exactly one tangent at a distance of 4 units from one of the focus. From one of the focus, there is exactly one tangent at a distance of 4 units. This ellipse will be flattened towards x-axis. Why? Because a square minus 16 will be less than this. All right. Next is, if there is exactly one tangent means from one of the focus. See, if you go above or below, you will be having the distance of the tangents equal. Now what they are saying that exactly one tangent to the ellipse at a distance of 4 units. It can be like this or it can be over here also. That we have to identify. This will be greater than 4. I mean a square minus 16. ये बड़ा होगा. अच्छा. Because a is greater than 4 लिखा हुआ है. It has been given that a is greater than 4. That means this distance is greater than 4 units. So ये 4 units से तो बड़ा ही. So this can be. And now what they are asking, the length of the lattice rectum. Okay, for length of the lattice rectum, we want B and A and eccentricity also. Chalo, what is this distance, beta? This distance is A minus AE is equal to 4. A minus AE is equal to, this will be the time. This total distance is A and this is AE. AE comma C. So A minus AE is, take A into 1 minus E is equals to, yes, and what is eccentricity? What is eccentricity over here? That is, if you square it, yeah, chalo koi baat. A into, I'll write it like this, 1 minus E is equal to 4 upon A, or I can take it as E square is equal to 1 minus 4 upon A ka whole square. What is E square? E square is 1 minus A square minus 16 upon A square is equal to 1 plus 4 4s are 16 upon A square. 16 upon A square minus 4 2s are 8 upon A. 1 and 1 is cancelled. Now we can simplify it and get the result. This will be equal to minus, that is 16 minus A square divided by A square is equal to 16 minus 8A upon A square. Now A is not 0, so cancel kar. You can get the value of A over here. ये A square से cancel हो जाएगा. So A is equal to, you'll be getting A is equal to 8, I think. A is equal to 8. A will be equal to 8. Correct? So if A is 8, then what is B? B is 8 8 is 64 minus 16. We can get B also. B is equal to 64 minus 16, which is equal to 48, I think. So length of lattice rectum is equal to 2 into B square upon. That is 2 into what is B square? Oh, sorry, this is B square. This is B square is 48. 48 upon A is 8. 8 6 are 48. 6 2 are 12. 12 is 7. Any doubt? What you should understand in this problem is, they are saying that there is exactly one tangent at a distance of this much particular unit. Exactly one tangent means it will be either on that side, either on this side, at the end of the major axis. It cannot be at this particular point. See, these 2 points are symmetric. Hence, you will be getting 2 tangents. If they are like this, you will be getting 2 tangents. एक यहाँ पे और एक यहाँ पे. Okay, all right. Let us discuss third problem also. Which of the following is a common tangent to the ellipse? Let us discuss this problem. Problem about common tangents. Shall I erase it now? Okay. Now let us discuss about common tangents. Which of these is a common tangent to the ellipse, this and this? All right. We have 2 ellipses. What are they? X square upon A square plus B square. X square upon A square plus B square plus Y square upon B square is equal to 1. This is one ellipse. Another ellipse is X square upon A square plus Y square upon A square plus B square is equal to 1. Now, for any line Y is equal to mx plus C, if they are common, if this line is a common tangent to this and this, C from this and C from this will be equal. Hence, we can get the value of m. C from this and C from this will be equal because the line will be same, m will be same. Getting my point? Common tangent ke liye what we will do? Okay. Now let us equate C. For this, C square is equal to A square plus B square into M square plus ka B square. For this, C square is equal to A square into M square plus A square plus B square. Now let us equate these two. So a square plus b square into m square plus b square is equal to a square into m square plus a square plus b square. Let me multiply it. A square m square plus b square m square plus b square is equal to plus b square will be cancelled, is equal to a square m square plus का a square ये भी cancelled. So m is equal to plus minus a upon b. You can take one m. You can take any m. That is, you can take m is equal to a upon b. So let us take m is equal to a upon b. Let me take m is equal to a upon b. So if m is equal to a upon b, what is c square? Sir, c square is equal to a square into this is equal to a square upon b square plus a square plus b square. What is it going to be? A power 4 plus b power 4 plus a square b square divided by b square. That means c is equal to under root of, I am taking only with positive sign, a power 4 plus b power 4 plus a square b square upon b. This is my c, this is m. You can write the equation of the line and get the result. Y is equal to mx plus c. There will be more possibilities. Negative, you can, if you take c negative, then that can be also a possibility. All right. And if you take m as negative, that is also a possibility. All right. Now, I think we all are clear about tangents. Locus of the foot of the perpendicular. All right. Shall we discuss more questions? So let us discuss two more problems. Let's discuss two more problems. Question number. So leave 9. चलो okay, do 9 also. अच्छा 9 छोड़ दो. Do only 10th problem. Only 10th problem. Leave 9. Solve question number 10. You have to find the locus of the foot of the perpendicular from origin. C, that is origin, center of the ellipse, that is 0, 0 on any tangent. For such type of questions, what you should do is you can use parametric form of the tangent. That means you can write the tangent for any parametric point, that is a cos theta comma b sin, and then you can find the locus of the foot of the perpendicular from C, from center. If you have to find the foot of the perpendicular on this tangent, you have to find that particular point h comma k. You can put that foot of the perpendicular as h comma k. We can do it like this also. Tangent at any point is x into cos theta upon a plus y into sin theta upon b is equal to 1. At any point, this is a tangent, this is a point h comma k, and this will be foot of the perpendicular from center 0 0 to this line. और ऐसे नहीं करना है, तो one more way to do it. One more way to do it. You can write the equation using y is equal to mx plus c. This is a tangent to an ellipse for which c square is equal to a square m square plus. All right. Chalo, first of all, please tell me h comma k will satisfy it. Yes, sir. H comma k is going to satisfy it. So I will put k is equal to mh plus c. All right. All right. Now I can write k minus mh whole square is equal to c square. Yes, sir. I can write k minus mh whole square is equal to c square. Now c square can be written as a square m square plus b square. Only problem is to eliminate this m. Will get the locus. Only problem is to eliminate this m. Now, what is m? Sir, m will be the slope of this line is k upon h. So slope of this tangent will be minus of h upon k. m1 m2 minus 1. m1 m2 minus 1. So put m is equal to minus of h by k over here. So k minus h into minus of h upon k whole square is equal to a square into m square is h by k, h upon k whole square plus ka b square. That means this is k square plus h square whole square is equal to a square h square plus b square k square. That means x square plus y square whole square is equal to a square x square plus b square into y square. Any doubt? Any doubt? No doubts? Any doubt? All right. Let us discuss about normal. Let us discuss about normal to an ellipse. Let us discuss about normal to the ellipse. Acha, we can find the point of tangency also. There is a formula for that, which we can derive easily. But no need to remember that. कैसे करेंगे? That I will tell you. Shall I erase it? All right. Let us discuss about normals first. Normal to an ellipse. Normal. Please tell me if this is a point on ellipse x1 comma y1. What is the equation of the tangent? Sir, it is x into x1 upon a square plus y into y1 upon b square is equal to 1. This is tangent. So slope of the tangent into slope of the normal is equal to minus 1. What is the slope of the normal? That is equal to minus 1 upon slope of the tangent. What is the slope of the tangent? Please tell me. So slope is minus का coefficient of x upon coefficient of y, that is b square upon y1. Yes. So this will be equal to reciprocal of this. That means it will be equal to b square into y1 upon a square. Oh, sorry, b square into reciprocal of this minus 1 upon. So that is a square into y1 upon minus times. So minus 3 already here. Plus times of a square into y1 upon b square into x1. This is slope of the normal. So that means equation of the normal will be x y minus y1 is equal to a square into y1 upon b square into x1 into x minus x1. Please tell me quickly, rearranging these terms, y into b square into x1 minus b square into x1 into y1 is equal to a square into y1 into x minus a square into y1 into x1. Quickly tell me, if when we will rearrange them, what I will be getting? I will be getting something like this. It is a square into y1 into x minus b square into x1 into y is equal to a square minus b square into x1 y1. And if I divide it by x1 y1, both sides, I'll be getting a square into x upon x1 minus b square into y upon y1 is equal to a square minus b square. This you have to learn. This is the equation of the normal. But ye bar we cannot derive in this way. So the equation of the normal is a square into x upon x1 minus b square into y upon y1 is equal to a square minus b square. Not 1 on that side. That is equal to a square minus b square. Whether a is greater than b or a is less than b, the equation will be remain same. It will not alter. It will not change. The equation of the normal to the ellipse is a square into x upon x1 minus b square into y upon y1 is equal to a square minus b square. Any doubt? Now, if that x1, y1 is a parametric point, if you don't want to write the derivation, no problem. You can just simply write this equation. You should know how to derive it. Ye pata hona chahiye, that's it. Now, if this point is a parametric point, so for parametric point, if the point is a cos theta, x1 comma y1 is replaced by a cos theta comma b sin theta, the normal equation will be a into x upon cos theta minus b into y upon sin theta is equals to a square minus b square. Now we'll be solving some questions based on this result, based on the equation of the normal. We'll be solving some questions based on the result of this normal. 5-6 problems. Shall I give you questions now? Done now? Okay. Written? Written everything? Okay, okay. Do more problems? All right. First and second problems are of tangent. You can start from problem number third. Problem number third. You can start from problem number 3. Is the normal at one end of the lattice rectum of the ellipse. All right. Normal at one end of the lattice rectum. What is the one end of the lattice rectum? What is one end of the lattice rectum? I will make you solve this problem. You have looked into the problem now. What is it saying? Okay. If the normal at one end of the letters rectum, x square upon a square plus y square upon b square, there is a normal to this ellipse at one end of the letters rectum, that is ae comma b square by a. This is the end of the letters rectum. At this particular point, normal is there. This normal is intersecting the curve again at one end of the minor axis. It is saying like this. So can I write the equation? Please tell me what is the equation of normal. X into a square upon x1 minus y into b square upon y1 is equal to a square minus b square. Quickly tell me, while if I put x1 as this and y1 as this, what I'll be getting? I'll be getting a square into x upon a into e minus y into b square upon y1. y1 क्या है? What is y1? y1 is b square upon a. So this is cancelled, this is cancelled, this is cancelled, is equal to a square minus b square. Hence I will be getting a into x minus a into y upon e is equal to a square minus b square. Now this is the normal which is passing through 0 comma b. On putting 0 comma minus b in this, we will be getting minus of a into b upon e is equal to a square minus b square. That means eccentricity is equal to, wait, this will be a upon ax upon e minus a into e square. यहाँ पे this will be 0. Okay, this is minus a square minus b square. All right, ठीक है. Now I'll be getting e is equal to minus of ab upon a square minus b square. ऐसा लिख सकते. And now what I will do, इसमें I have to arrange this eccentricity का formula. E square is equal to 1 minus b square upon a square. So that means e square is equal to a square minus b square upon a square. No problem. A square minus b square upon a square. I will square this also. So e square is equal to a square b square upon a square minus b square का whole square. But I want the answer in eccentricity only, e only. I want the answer in e only. And that means I have to eliminate a upon b or b upon a. मुझे b upon a को eliminate करना है. How I will do it? ae comma b square by a square into x upon x1. I have to eliminate b in this. b और a को eliminate करना है. So e is equal to minus of ab upon कुछ. There is a slight mistake in this. कुछ गड़बड़ कर रहे हैं. Okay, sorry. Mistake is this. Actually, what I am doing is putting the points incorrectly. X coordinate will be 0, y coordinate will be minus b. That means it will be equal to ab is equal to a square minus b square. For this, ab is equal to a square minus b square. When you put minus b over here and x as 0, so ab is equal to a square minus b square. Correct? So now please tell me what is eccentricity. Eccentricity is equal to 1 minus b square upon a square, which is equal to a square minus b square upon a square. Please tell me what is a square minus b square. So that is ab. That is ab. So e square is equal to ab upon a square. A and a is cancelled. So eccentricity e square is equal to b upon. Correct? E square is equal to b upon a. Hence, e square is equal to 1 minus b square by a square. So e square is equal to 1 minus e square. So e power 4 is equal, sorry, e square, 2e square E square is equal to 1 by 2. We get eccentricity. Now we can check for the options. ठीक है? Now we can check for the options. या उसकी जरूरत नहीं है. This will be e power 4 I think directly. वो ऑप्शन डायरेक्टली मिल जाएगा. This equation will turn out to be e power 4 plus e square is equals to 1. Any doubt? Initially we were putting the point incorrectly, na? I was putting x as minus b and y as 0. That was not right. That was incorrect. Put x is equal to 0 and y is equal to minus b. So ab is equal to a square minus b square. So e square is equal to 1 minus b square by a square. And now we will put a square minus b square as ab. That means e square is equal to b upon a. Hence, what is the formula for eccentricity? That is 1 minus b square by a square, b by a whole square, b by a e square, that is e power 4. E square is equal to 1 minus e power 4. Any doubt? No doubts? All right. One more problem we'll do. Do problem number 4 and 5. We have almost finished ellipse. We can start with hyperbola now. Acha, rest all the properties, chord of contact and chord with a given midpoint, that is same as we have discussed in circles. T is equal to 0, T is equal to S1, SS1 is equals to T square. Everything is same over here also. Question number 4 is saying the equation of the normal to the ellipse at the end of the lattice rectum in first quadrant. So simple question. So simple question. Directly you can write the equation. I have written on the board. That is ax upon e minus a into y is equal to a square minus b square. Only changes a square minus b square is equal to a square e square. Only changes a square minus b square is equal to a square into e square. Replace a square minus b square with a square into e square. You will be getting the result. Any doubt? Replace a square minus b square with a square e square. You'll get the result, whatever has been asked. Any doubt? Any doubt, Chinmay?
No, sir.
Question number 4. All right, chalo. Question number 5. I'll tell you. If the normal at one point theta intersects it again at another point on the ellipse, which is 2 theta, then what is cos theta? They are asking you cos theta. Theta पूछ रहे, cos theta पूछ रहे. So this is an ellipse. ये एक इलिप्स, यहाँ पे किसी पॉइंट पे थीटा पे यू आर गेटिंग अ नॉर्मल that is intersecting it again at a point 2 theta. So let us write the equation of this normal. Sir, it is x into a upon cos theta plus y into minus y into b upon sin theta is equals to 1. Is equal to a square minus b square. Chalo. Now this normal will pass through 2 theta. This point 2 theta. So what is 2 theta? So a into a cos 2 theta upon cos theta minus b into b sin 2 theta upon sin theta is equal to a square minus b square. So what is a square? Please tell me what is a square. A square कितना हो रहा है? It is 14 and b square is 5. So it is 14 into cos 2 theta upon cos theta minus 5 into 2 sin theta into cos theta upon sin theta is equal to 14 minus 5. Now cancel kar do. Everything will be in cos theta now. Expand cos 2 theta as 2 cos square theta minus 1. You'll get a quadratic in cos theta. You can solve it. So if you want, I can solve it for you. It is 14 cos 2 theta minus 10 cos square theta upon 5, upon is equal to 14 minus 5 is 9, 9 cos theta. 14 minus 5 is 9. 14 cos 2 theta is 2 cos square theta minus 1. So 14 2 is 28 cos square theta minus 10, 18 cos square theta minus 14 minus 9 cos theta minus का 14 is equal to 0. Check कर लेना, you can get what is cos theta. Any doubt? These problems are very simple. ऐसे ही problems you will be getting in JEE Mains also. So you can solve last year problems, previous year questions. Okay. 2 to 3 more properties in ellipse which are important is left. That we will discuss tomorrow, and we will start with hyperbola. Any doubt? No. ಏನಿದ್ರು ಸಮಸ್ಯೆ ಉಂಟಾ? ಇಲ್ಲ. ಏನಿದ್ರು ಸಮಸ್ಯೆ ಉಂಟಾ? ಇಲ್ಲ.
ಇಲ್ಲ
Okay
sir.
then. Okay then. Rajay now. Enjoy.